Hello, everyone. I'm Sally Yan, Software Development Manager in DevOps. Today, I'm with our Product Manager, Thomas Pangborn, to talk about our IaC. What do we do with IaC? How do we do it? So, first, what is IaC? Infrastructure as code is a powerful paradigm for provisioning, configuring, and deploying an environment. In the IaC model, provisioning compute resource is done by lines of code. Getting rid of those error-prone manual steps, in other words, is really codified configuration management. The two approaches in IaC, declarative and imperative. In the declarative approach, you declare what the desired end state should be. The automation platform determines how to get there and will get you there. It requires less knowledge on the user's part because a declarative language just defines the final state that you want. You always end up in the same end state no matter where you start. In the imperative approach requires you define every single detail steps, the process explicitly to reach the desired state that you want. It allows you to build a very complicated, automated process, layers of command lines. But you must have good knowledge to tell the automation platform what to do. Imperative language envisions a task as series of predefined steps that could take you to a different endpoint depending on the start point. So, why infrastructure with code is important? Cloud technology is taking over the modern business world. We all want to be on cloud in some way. But at the same time, there's a lot to learn and understand about what is cloud. Infrastructure like Kubernetes clusters, node pool, ingress, egress, traffic, load balance, different type of security. The list can go on and on. Think about this. If everybody on your team has to understand all of this before getting a single deployment, how long will it take each time? With IaC, we can increase productivity through automation because it codifies everything for your infrastructure needs. You can also deploy cloud infrastructure in many different ways by providing the configuration file. You tell the system what you need, then you let the code do the rest. It improves the efficiency of the development cycle because now developer can focus on application development rather than try to get an environment to do their work. Tester can continuously test in different stages and different configuration, so teams can focus on other mission critical tasks. For speed, I can give you an example of SAS Viya deployment on Azure. To do it manually, you will need a dedicated person sit in front of the computer, run the command line a few times, watch it, wait, one a little bit more, and it takes hours. With the IaC approach, our deployment on Azure takes roughly 45 minutes. You script it once and use that code repeatedly, then save time and effort. Since the file are in version control already, the same configuration are being used over and over again without discrepancy. This codified method provides standardization and consistency. Because the code is in open source, with version control, we have full traceability of all the changes. Our goal. We want to be able to provide a stable, consistent compute resources for a successful SAS Viya deployment in the shortest amount of time in a repeatable way by defining resource configuration that we can version, reuse, and share. So how do we do it? We choose a declarative way. We're using Ansible, Terraform, and Terraform registry. So Terraform let us create, update, manage, and destroy infrastructure resources such as VMs and containers. Terraform registry is a centralized repository where we can find different providers and modules and use it with Terraform. These providers and modules are supported by the cloud providers, community partners, even individuals. It is open source. If you find the modules that you want, use it, put it in your configuration, run the Terraform init, automatically grabs everything for you. If you don't find what you need, you're welcome to run your own modules, right? Open source, you share out to the community, and that's the beauty of the open source. Ansible is used in our SAS Viya deployment, Ansible playbook. IaC and DaC are closely integrated. So if you use IaC to provision an infrastructure, it will retrieve the cloud configuration from the TF state file, and very simple, straightforward. But what if you don't have what if you don't have an IaC for provisioning? You can also still using DaC deployment as code. It's just a little more configuration you have to put in your configuration file. So standardize. We have 4 different projects in GitHub for Azure, AWS, GCP, and open source Kubernetes. So standardization is pretty important. You don't want to write things in different way everywhere, right? So using Terraform, we created abstraction for storage type, container, registry, jump boxes, node pool, database, ingress, whatever we talked about before. In this diagram, you can see it's pretty standardized. It's a unified structure across all platforms that we supported. While standardized, it's also optimized for use in each cloud by taking advantage of the benefit which exists in each vendor's cloud offering. So we heard enough about IaC, DAC. So let's look at how the actual flow. So here is a basic flow you can see. So let's say you don't have anything. You don't have any infrastructure to even begin with. You just want a Viya deployment to carry on your work, right? In this case, you will want to use IaC to provision the infrastructure. So to do that, you would just grab the IaC repo from the GitHub, set up an authentication to access your cloud provider, and modify the Terraform TFR file. And just some basic information, how you want to name it, your subscription, some basic information. Then you save the file, run the Terraform init to initialize the working directory for you. And you run the Terraform apply. And that's all you need to do to get your infrastructure up and running in the cloud. And then after you have the infrastructure created and you start deployment, right? So you can use DAC now. Very similar process, just like the IaC. You grab the repo and set up authentication, enter the Ansible var file, and run the playbook. And we have documentation in each of our repo. The README and the config var MD is really a good place to start. Flexibility. So you may ask, great, you give me all this default setup, and or what if I want to customize certain things to fit my need? I might want to have a bigger size pool, different number of pools, and what do I do? We got you covered. You can modify the Terraform file. You can change the Kubernetes version that you want, and you can add tags, change the number of node pool, the sizing, even storage type, database, or maybe even want to add logging and monitoring, change a different type of security. You want to do a front door, you want to do a full-blown, and they are all configurable. Capability, we support customized overlay, and you can bring in your own cluster. If you already have an existing cluster that you've been using and you want to keep it, you can do that. You just need to, like I said before, just a little bit more configuration into the configuration file to let DAC knows that is infrastructure you want to use. Bring your own networking. Private networking, a lot of people prefer to do their networking stuff, right? We can support that too. Also, proximity placement group on Azure. But this is a little bit costly because it needs to be stood up at once. But if network latency is an issue for you, you pay the price, to have the PPG. We support multi-tenancy in Azure, AWS, GCP, and we are working to get the single store with the DAC. So after all this talking, Thomas Pangborn, our product manager, is ready to show you a demo. You can watch how we can build from scratch, make some customization, and have SAS Viya for running in front of your eyes. So Thomas, to you.
The first thing that I want to show you is what I have on the browser right here. This is the Azure console. You can go here and look at several of your components that you have. I'm going to start with a resource group because a resource group in Azure is kind of like the overall encompassing item that you can go view things. So let's go here. I've got 2 systems set up for the Explore demo. One of them is the blue and the green. Kubernetes cluster. The blue one's kind of my active one that I'm currently working in. So if we click here and look, you can actually see these are the elements that I've stood up using my IaC code base over here. This is the infrastructure file that I use to describe what's going on in the cluster itself. And then once the code was run, this was the environment that was set up. You can see here there's several things. One of the things we want to talk about is tags. Tags are resource elements that are assigned to cloud components. They're not part of Kubernetes itself, but they're part of the cloud provider. So you can see here, I've got resource owner, project name, and environment. Those are showing up here inside of my cluster. I've got a little demo here where I'll add one of those. You can see we've stood up a Postgres server by default. Sorry for the scrolling. Postgres servers, just one. You have to scroll through the information that's here, but you can see the Postgres server. You can also see the Kubernetes cluster. So let me just jump into that really quick. So if I click on that, this takes me inside the Kubernetes cluster that I've stood up. There's a lot of information here. You can see the Kubernetes version. You can see the pod CIDR, the service CIDR, DNS service IP inside the cluster itself. There's a Docker bridge if it's running Docker. IP ranges, these authorized IP ranges are set up when you configure your system. This allows the security protection to keep out IPs that we don't want. You can see that there's quite a few listed here. Most of these or all of these are actually SAS VPN IP ranges, so that keeps everybody out that's not part of SAS. Since this is a cluster, you can go in and look. You can check out the namespaces. So currently there's nothing deployed into it. Workloads, you can see services and ingresses if they're there. There's just a few that are active. If there's node pools, you can see that they're there. So as you can see here with my generic setup, what I did is I set up a CAS node pool, which has 0 to 5 and 0 to 5. Those don't have any actual nodes running at this point in time. The system node pool always at least has to have one node running, and it's there. So I wanted to go ahead and show you that. So this gives you insight into your cluster. You can also do that with Lens. I know I'm kind of jumping off script here a little bit, but this is the Lens hooking into the kube config file that was generated from my IaC code base. And you can see here, it's showing me that I only have a system node pool or system node active in the cluster. So if I jump back to my browser and look, you can see, yep, that is actually true. So the next thing that I'm going to do here is I'm going to go through and modify this so that you can see infrastructure changes. So if I wanted to add a tag to resources, I'm just doing the demo tag, it's sample, and I might want to add an extra node pool into the cluster. So I want to do that. So if I want to do that, all I have to do is, I just have to do that, and then I have to rerun the Terraform pieces. So if you look, I'm in the public directory of my repo. You can see I have my Terraform state file here. That's listed and everything. So what I'm going to do is Terraform apply. I'm going to auto approve that and run this on the cluster that I currently have. The way that I'm running this, you can see that I have an internal use only TFR file, which is what I'm using here. This basically just overrides variables that would have been in the examples file. So the base example file that I'm using, and I'll make this just a tad bigger now that things are running, is this minimal component. So if I look in here, this is what minimally is set up. So I'm actually overriding those minimal components or items that I would like to override. So at this point in time, it's going to be updating elements inside of my infrastructure, inside my resource group. So I'm going to go ahead and refresh. What will happen is that eventually you'll see tags show up. And because there's more than just the 3 that we saw earlier, you can see now that the demo tag is showing up. With the demo tag showing up, we know that the infrastructure is being updated. You can refresh here. It doesn't always show up here, so you do have to go in and jump in. The other thing you can look at is you can look at other things, like this is my Postgres server. So when I go jump in here and look, it's going to connect to that. If you go look at the tags here as well, you'll see, oh, wait, what's going on? They haven't updated. It's like, yep, that's true. So if you look here, we're still updating our Postgres server. You can see that it's still modifying the elements inside the Postgres server. So those particular tags haven't been updated at this point in time, but eventually they will. It'll catch up. So where will we go next? So with this moving on, what I want to jump to now is I want to show you a second repository or a second Kubernetes cluster that I actually have. So I have one called Green, and they're really not green blue. It's just kind of a name I used really. This particular one has a different setup. So if you look at my first environment, it's got an NFS server with NFS disks and rated component. My green one's more HA because I use the HA storage class. So it has my NetApp account capacity pool and my volume that are all here for my NetApp server. If I go look here inside of this cluster, you'll see some different things. We'll go to namespaces, and you'll see here, oh, there's a whole bunch. There's the Ingress Nginx components, there's NFS client, THPangDev, which is my SAS installation. So there's a lot of components inside of this cluster. I can go here and look at my services. This also has an external IP because my Ingress Nginx controller now is active inside the cluster. If I go look at my node pools, you'll see that these node pools actually have a number of nodes active. If I go here and look, oh, it's updating it, so it removed the file. So let me wait for that just a second. So, no, that's the blue one. We're okay with that. Let me jump here. Yep, here we go. So you can see it's got 2 generic nodes and a system node and the cast node pool. If you look at the cast node pool, it does have the taint associated with it. And that lets it know that only cast services can run on this node. Again, this is Lens. I jumped kind of from Lens from the regular console. So this is the cast server default. That's the only thing that's running in this node pool. So let me jump back to my information here. You can still see that the Kubernetes cluster information is still updating. So that's working pretty well. The next thing that I wanted to show you is because we actually do have, or not because, but in this cluster, I already have SAS software deployed. So if I go look at workloads here, and I can filter on my namespace, you can see all the SAS pods up and running. I'm going to jump to Lens really quick. It's the same type of thing. I can look here and see that. So if I switch between the two, you can see they're providing the same information. If you look here, so we have done the update. There's 2 added, 18 changed, and 1 destroyed because it had to remove the kubeconfig file and start it back up. So my infrastructure changes have taken place. So now that we've seen that the tag updates have taken place inside of the resources that were installed in the cloud provider, I wanted to go show the Kubernetes changes that actually took place. If you remember, we actually added in the stateless node pool. So let me jump here. If we look, we have to go to node pools again. Again, there probably won't be any active pods, but you can see since we don't have SAS deployed, but there is now a stateless node pool that is actually up and running in our cluster, which matches the information that we passed along into Terraform to stand up the infrastructure. So as you can see, there's a one-to-one correlation with the code base that you have, the Terraform variable file, and the infrastructure components that are inside of the cloud provider and or inside the cluster that you've stood up. The good thing about Terraform is that Terraform is you kind of implicitly tell it what you want. You define exactly what your infrastructure is going to be, and that's what Terraform tries to build inside the cluster for you, or not the cluster, but in the cloud provider. With that, there's nothing that's left to question or anything like that. All of the items that you have defined will be actually here, the blue side of things, because this is where we actually change everything. There's the demo tag. I'm jumping around inside the green environment, wondering why I can't see it. There's the demo tag as well. So the tags have been applied to the elements inside of the cloud provider. So now that we can track that, again, this guy doesn't have anything active. I go look at namespaces and stuff. This is kind of a clean, raw Kubernetes environment. There's nothing to this one at this point in time. If I go back to my resource groups and go to the green side of things, again, this cluster actually has active node pools, as you can see, and it's got the workloads active for SAS. It doesn't remember the namespaces, but we can jump to that. So from there, what I want to do is I want to show you that SAS is up and running. We have an Open LDAP server that runs by default. You can see it's logging me in. It jumps me right into SAS Drive. Things are active here. I'm logged in as the administrator. If I go like develop SAS code, this will start up SAS Studio. And let's see how that looks. Yep, perfect. So what this is doing is this has SAS Studio up and it's got the compute context up and running. So the next thing that I want to show you is that inside of the infrastructure side, what we can do is we can do a couple of things. The process for taking down a cluster is exactly as it is when you're standing it up. You basically uninstall the cluster. You uninstall it. For Azure, it's not really as much of a big deal because in Azure, you can just delete the resource group and it will destroy everything underneath that resource group. Your cluster and everything, it won't ask any questions. But any SaaS software that's been deployed, your storage classes that's storing things or anything like that, all of that information will be lost. It will just nuke it completely. If you want to do backups, you can scale down SAS, take backups of the data that you want, and then run Viya uninstall. And I'm going to go ahead and start that right now, just to show you that that's active. That's going to read through the TF state file and start kind of processing through the order again, and then it's going to hook into the cluster and start deleting the namespace. This does take a little while, so I just kind of wanted to show you what's going on. This will basically uninstall the thping dev. It'll only uninstall the SAS components or the Viya components. The other elements are part of the baselining, this NFS client, Ingress, Nginx, metric server, and things like that if it needs to install. Since those are not part of the Viya component, it will not remove those. You actually have to do baseline uninstall as well. And then once you've done that, then you can do your Terraform destroy. That's the process that we typically talk through. So thank you so much for your time today. Everybody have a great day, and I'll talk to you soon.
Thank you, Thomas, for the demo. Great. So all of our code are in GitHub. We write code. We welcome contribution from anybody, open source. We do code review. But to get the code to production, one thing we must have is quality. In the CI/CD world, everything is continuous. Of course, we need test automation. It is part of our IaC development process. We created test automation pipeline. So this pipeline can run in multiple ways. First, by default, it is set up to run daily whether we have code changes or not. It will create infrastructure on any clouds that you choose, deploy Viya into the infrastructure, and run the regression test. This is to capture if there are any unexpected or unforeseeable changes from our third-party vendors. Second, we use webhook and GitHub actions. The pipeline will automatically kick off and execute a set of regression tests when it detects the new changes, new merges in our GitHub branches. Third, it can also be run as an on-demand job. Developer could use this for sanity tests before even pushing the code and find the problem earlier before the code ends up to the staging or production. So far, we've talked about how IaC approach, show you how simple it is to create an infrastructure and deploy Viya in a very short time, and our deployment process and test process. So next, Thomas is going to share our roadmap with you guys. Yep, next, Thomas, thank you.
Hey, everybody. Let me go ahead and switch the slide here. So let me talk about the roadmap a little bit. So Sally alluded to the fact that we already are working on single store integration with the IaC and the DAC code base. We're moving forward with that pretty quickly. We should have that shortly. We're also focusing on FIPS. The big push, as Sally alluded to, with our GitHub actions and our testing flow, we're trying to integrate more security checking and validation into the IaC DAC structure and into our workload. So FIPS is very important. The focus there is to have a FIPS compliant Kubernetes cluster that's available to run the SaaS software. One focus that we do have in AWS that folks have been asking for is AWS FSx for Lustre. The focus there is to replace the EFS file systems with the Lustre file system. That is a little more complicated, but it's a little more flexible and cloud friendly. So we're looking at adding that in. We just recently got a push to have Anthos support on Google Cloud for folks who are Google customers that have on-prem VMs or physical hardware that they're looking to add to their GKE cluster. We'll have that shortly. And we're going to enhance our bring your own scenarios. Those bring your own scenarios, as Sally alluded to, were items where you have your own network or your VPN, items like that. So far, we've surfaced up kind of some basic elements. We have gotten a lot of feedback from consultants in the field that we just need to do a little more enhancement on that to accommodate for items that not all of our customers would have or that don't fit our very opinionated layout of the infrastructure. All right, and that's all I got for roadmaps. So from here, let me just tell you about a few different links. So as Sally said, the code base is all open source. So we have 4 infrastructure as code repos that are available for Azure, AWS, GCP, and open source Kubernetes. Those are all available to the public now. You can go check those out. They do follow the same standard. So if you're familiar with any of these and using infrastructure, they all take or have a very similar Terraform variable file that can be used and how to set things up. Then we have the DAC code base, which is the deployment code base, which does the baselining and the Viya for deployment into the Kubernetes cluster. The bottom link is the Viya for. It's the resource guide. The resource guide provides all of these links in an overlay, or not an overlay, but an overview of items that are integrated into the SAS deployment in the IaC code base. It talks about like our order, command line interface that we have. It talks about some other things about pulling your containers, the container registry from SAS and things like that. So the resource guide is a great place for you to start. So I hope you've enjoyed the information that we've shared today. Again, our door is always open. We've provided both of our email addresses. We are always on Teams. We have an infrastructure as code Teams channel that you can jump on if you need. We actually have office hours there. Right now, they're on Tuesday and Thursday at various times. Please check the channel, the infrastructure channel for those. We're trying to adjust those so that we can accommodate more folks across the globe. Tuesday's meeting is in the morning. Thursday's meeting is in the afternoon right now. Again, those are subject to change, so I'm not going to give exact times. So just check the channel for all of that. And again, if needed, reach out to Sally or myself or anybody on the team. We'll gladly answer questions and sit down and talk. Thank you guys for joining us and have a great day. Take care. Bye.